Hi, welcome to Petradot, and in this lesson we are going to be learning Stack in Java. Stack is a linear data structure that is based on the last in, first out principle, much like a stack of plates. Elements are added to and removed from only one end, that is from the top. So just imagine a real world scenario when you are going to be packing plates and you are arranging plates. You see that plates are actually arranged in a stack. So for you to pick out any plate means you are going to start from the top, right? So if you are going to remove, even if this is the fifth one, means you have to remove the first four ones at the top. So which is the core principle of a stack. The last that goes in is the last that will come out first. And stack in Java extends the vector class. That is, it is inheriting from the vector class with five operations that allow a vector to be treated as a stack, which these operations includes the push, the pop, the pick, the empty, and the search. We are going to treat all of them one after the other to see how they work. Then the usual push and pop operations are provided, as well as a method to pick at the top item on the stack. So and whenever a stack is created, it is empty by default. So to create a stack, it provides us with a default constructor, which you can define this way: stack, then you provide a type of item object is going to be holding. So we're going to create a stack of string. Say we want to hold names, so we want to stack names, then equal to new stack. So now, for you to be able to put an item on the stack, you use the push method, right? So it says here push adds an item to the top of the stack. But before that, let's check if there is an item in the stack, which we are going to be using the empty method, which tests if a stack is empty or not. So we'll do system.out.println stack names is empty. So let's check whether it is empty. So which is names dot is empty. So if we run this program, let's see what is going to happen. So it is empty, is showing true. So you can use this, the dot is empty method, to check whether the stack is empty or not, right? So let us add items and see. So say names dot push, then you add a particular item, say John. So when you now check whether it is empty on auth, you see that it will now be showing false. There is now an item on it, right? So let's just print the whole stack and then test run something. System.out.println names. So if we print this now, we'll be seeing the complete items in the stack, which is John. So let's push other items too to the stack. Names.push, say Peter. So then let's run this and see. You see that the item was added to the end, which is the top. So the right hand side is seen at the top of the stack. So if we still add an extra one item, let's add extra one item. Names dot, we must not use only push. So because the stack is inheriting from the vector class, it still added a method for us, which is the add. So we can use the add just like the list class to add an item to the stack, which is dot add. So when we use dot add, I can easily pass in another name, say Juliet. Then we save. You can see that the item was added. It was pushed to the queue. Now let's test run popping, picking, and to search. Now pop says it removes and returns the item from the top of the stack. So let's assume now we're going to let's pop a particular item. System, let's just do this first of all, names dot pop. So this pop is meant to remove the last item, which is Juliet, and leave us with only John and Peter, right? So let us print the stack again. So when you run this program, let's see what the result is going to show. So you see now, before we had John, Peter, and Juliet, but now it is only John and Peter after being popped, right? So, but when we do pick is used to detect the last item at the top. So it just picks out the item at the top without removing it from the stack. So for example, let's use system.out.println pick this stack pick. So we'll do names.pick, right? So let's see what the result is going to be. So it's going to return the last object on the stack, the one that is meant to be popped next if you are to pick an item from it. So you see it returned Peter here because Peter is the next one at the top, right? So what else is left here? We have not checked search. Okay, search returns the distance to the last position, returns the object distance. Let's say if I want to search for John, so I want to know the distance John is to the last item to be popped, or if I want to search for Peter, right? So let's say we want to search for John. Let's see what it's going to return. So it will return a positive number if John exists, but if it doesn't exist at all, it will return -1. System.out.println names.search, and we are going to be searching for John. You can see here it has the distance of John to the top is 2. So for you to be able to pick John out, you have to take it 2 steps, which is first of all remove Peter first, then you meet John. But let's check that of Peter and see. So search for Peter. You see Peter is returning 1. It's just a single step. So the only distance from Peter to the last item to be popped is just 1. And now let's search for an item that is not existing. Let's search for Patrick. And we are having -1 because Patrick is not existing. Alright, so that is all about a stack. To recap, we say that a stack in Java is a linear data structure that is based on the last in, first out principle. One of the places you can implement this in real life is if you can remember your undo in your computer. Anytime you perform an operation, the actions you performed are being stacked. For example, you typed John initially, and you typed Peter, and you typed Juliet. These items are being stacked. When you do press undo, that is Ctrl Z, the Juliet is being popped. That is exactly what happened here, right? So that is a real life scenario of where it has been implemented in a computer. So stack is just a linear data structure that is based on the last in, first out. The last object you added to the stack is the first object you are going to pop before you can access the next one. Alright, thank you for watching. If you have any question, do well to drop it on the comment section, and don't forget to like and subscribe. Thank you.